And welcome to our 5th edition of Emissions Talks webinar series hosted by Process Ecology. I'm Sophia Alva, your host for today. Today, we will be talking about turning data into action and real-time insights for tank emissions. As methane regulations tighten across Western Canada, oil and gas producers are entering a new era of accountability and opportunity. What once was considered controlled is now under increasing scrutiny, particularly emissions from storage tanks, which are proving to be significant sources of methane. Today's webinar will dive into this evolving regulatory landscape and what it means for operators. We'll touch on federal and provincial mandates from Alberta and British Columbia that emphasize continuous real-time monitoring over traditional spot checks. While new requirements point toward costly continuous monitoring systems, our approach offers a smarter alternative. By leveraging process data, we can anticipate emissions events and validate them using facility-specific context, reducing reliance on sensors that may produce false positives. From process data to root cause analysis, we'll show how solutions like RT-GHG, our real-time emissions tracking platform, are helping operators go beyond regulatory requirements to uncover emissions events as they happen, identify root causes, and unlock real cost and carbon savings. We'll also be sharing results from our RT-GHG pilot project at Tourmaline's Wolf Lake facility and how your facility can get involved to stay ahead of regulatory changes while building a stronger emissions profile. Joining us today, we have James Holoboff, our Chief Operating and Financial Officer, and he brings 20 years of expertise in emissions data management and compliance best practices. He develops optimal strategies and emphasizes the importance of data management tools to automate processes. Welcome, James. We also have Gabe Mathias, one of our engineers and software developers with a background in chemical and software engineering. At Process Ecology, he focuses on developing advanced tools for emissions tracking and process optimization in the oil and gas industry. He is the lead developer of RT-GHG, integrating first principles modeling with SCADA data to improve regulatory compliance and operational efficiency. Welcome, Gabe.
Hello, everyone. Great to be here.
Yeah, good to be here. Thank you.
So now James and Gabe will go over their insights. So please feel free to submit your questions in the Q&A box available to you throughout the presentation. It should be on your right side of the screen. We will get to these questions at the end. So James and Gabe, you're free to start presenting.
All right. Thank you very much, Sophia. Yeah, Mariana, go ahead and start that presentation, and let's go to the agenda. So today we're going to start with an introduction to real-time tracking and continuous monitoring, discuss some of the applications for real-time plant data monitoring systems. Next, talk about the introduction of continuous monitoring into emissions regulations, in particular methane regulations, and why this matters. Then we'll talk about some of the challenges and opportunities around continuous monitoring, both the kind of the measurement device-based continuous monitoring as well as the plant data monitoring system like RT-GHG. And then Gabe will talk about some of the RT-GHG findings at Tourmaline's West Lake facility. Next slide, please. All right, so introduction to real-time tracking and continuous monitoring. So when we talk about continuous monitoring, often we're thinking about, measurement devices, but what I'm talking about specifically here in this slide are plant data monitoring systems. These are systems that are developed from plant data coming from SCADA or historian systems, things like pressure, temperature, flows, compositions. This data is brought into essentially a process model that's solved on a real-time and continuous basis. And then we can use the model to predict things like emissions intensities, and other parameters. Some of the opportunities that we see include addressing dynamic emissions metrics for ESG. Companies, or many companies report ESG on an annual basis, but typically they're looking for information on a more frequent basis. They want to know what, like quarterly or monthly. They want to know when things happen in the process at their facilities, how that might impact ESG reporting. And sometimes finding that out at the end of the year is a little late to do anything about. The next one, carbon cost evaluation, and the same thing. Companies have a carbon cost obligation. At many of their facilities, they want to know not at the end of the year when they're determining how much the carbon cost is, but they want to know if changes in operation or changes in the way the facility is operated could have impacted or minimized their carbon costs. The next one, gas recovery and energy reduction. Like I mentioned earlier, real-time RT-GHG is essentially a process model. We're predicting not just emissions, but also heat duty streams for, say, reboilers or compressor duties, as well as material streams, for example, products, flow rates, compositions. So we're able to use it not just to estimate emissions, but also look at, maybe optimizing the facility or reducing energy use. The next one, root cause analysis, and Gabe is going to go specifically into this one, but you can imagine that a measurement device can, give an indication when an emissions event is occurring. However, a plant data monitoring system gives us the ability to evaluate why that's happening, and we believe provide a better quantification of those emissions. The next one, on the regulatory side, as well as voluntary reporting. Some companies are looking to more and more automate the process of regulatory emissions reporting and real-time data monitoring systems, especially for large plants, provide the potential to be able to automate that. On the voluntary side, we see reconciliation of bottom-up and top-down estimates. And real-time plant data monitoring system provides a much better comprehensive bottom-up estimate than the conventional methods. Next item, stakeholders can use the system for enhanced business decisions. And the last one, with credibility. So in other words, companies are making claims regarding the credibility of, or I should say, they're making claims regarding emissions or emissions intensities, for example. Plant data monitoring system provides the ability to support those claims. So go to the next slide. Just talk briefly about the introduction of continuous monitoring and regulation. So first, in the federal regulation, this was introduced about a year and a half ago, still in draft, but it introduced continuous monitoring as a performance-based approach as an alternative to surveys. Next, in Alberta, we see within Directive 60, and of course, methane regulations are part of that. Recently, effective April and even more recently, June, that directive was updated. But one section in particular was the LTFMP, which provided the ability for a continuous monitoring program to be implemented without upfront approval of the AR, as long as it meets documented standards. So this is a significant change in the way these continuous monitoring programs can be implemented. And the third example is in BC. and the drilling and production regulation effective January 1st, 2025, we see that there's a requirement to install fixed leak monitoring devices on all control tanks, and this is by 2028. So just to summarize, we see within these regulatory frameworks that continuous monitoring, and this is certainly addressed at measurement devices. But as we go into the next slide, we see how there are challenges with the continuous monitoring devices, and of course, we see that monitoring devices as an important part of emissions inventories. However, there's challenges that in many cases can be addressed, maybe supplemented or made even better by plant data monitoring. So first, we see that false positives, certainly we've seen that to be a challenge, particularly if those devices are used for operator notification. Where plant data monitoring can address that is in providing much lower rate of false positives, because it's based on operating conditions. We've got significantly less risk of misidentifying emissions events. The next one, what are we measuring? Of course, these devices generally measure concentration. The placement of these devices, as well as the type of device or the way that the conversion is done from concentration to flow rate, and ambient conditions as well, can make it very challenging to accurately measure, quantify, and determine the source of those emissions. On the other hand, for process-related sources, a process model, which is the basis of a real-time plant data monitoring system, can provide very good quantification as well as source determination. And the third point is they can be costly, particularly for full plant coverage, where maybe you have quite a number of devices around the perimeter of the facility. In the case of plant data monitoring system, it's scalable. We can see the entire process, and we can use this system not just for emissions, but for other applications, as I mentioned before, energy and production optimization. So going to the next slide. So we see a growing role for real-time plant data systems like RT-GHG, which is pictured here. Go ahead there, Mariana. Plant data monitoring systems are a significant advancement in emissions management. They provide real-time visibility into key emission metrics, enhance credibility and transparency to support emissions claims. And finally, they predict emissions events and can provide insight into root cause. So last slide here, this is not vaporware. We're actually doing this in the field. We've done it with entropy and tourmaline with support from Alberta Innovates, as well as new installations. So this is something that's out there. And Gabe will provide a specific example in the following slides. So over to you, Gabe.
Great. Thanks, James. So I'll be going over some of the findings we've had at the West Wolf Lake facility. Like James said, this is a case study. We did it. We're deploying RT-GHG at the moment right now, and we're getting results, and we're going to present some of those to you right now. So just looking at the facility itself, this is West Wolf Lake. It's what it looks like. The facility is a testing facility by NGIF. So we have the luxury of having these sensors. We have a point sensor on top of the tank farm, right on those black cylinders. That's the tank farm. We have a perimeter sensor around the facility. And these sensors are all atmospheric sensors. They look at the atmosphere, see if there's any concentration of methane in it. And then they estimate flow rate based on the concentration and the wind speed and those kind of data points. And then right now we have RT-GHG deployed in West Wolf Lake. So we're monitoring the entire facility and getting KPIs and estimating emissions for the entire facility. Today we're going to focus in on the tanks because that's the case study that we have for you. But keep in mind that is looking at the entire facility. So just with the tanks, the first step that we had for the tanks was to tune the set points of the safety devices in the tank. So the problem formulation for the tank is usually you have stuff coming in, and that's all calculated and estimated by RT-GHG, the inlet. And then you have a level transmitter. All the tanks are attached to the VRU through a header, and there's a compressor for the VRU. And they have safety devices, so a PVRV and a thief hatch. Whenever the pressure in the tank builds up, those open so that the tank doesn't explode. So it's a good function it's doing. And this graph here, you can see in the purple line, you can see some sort of chattering behavior. So the pressure builds up, the PVRV opens, the pressure goes down, and then the pressure keeps building up, PVRV opens, pressure goes down. There's a clear ceiling that you can see from the graph. And that first ceiling right there is the PVRV set point. But if you keep going, next slide, please. Yeah, so if you keep going at 12 p.m., it built up even more, and that's because the PVRV was not enough to relieve the pressure, and the thief hatch then had to be open to relieve that pressure. So from this graph, we got experimental values for your set points for the safety devices. Once we had the experimental values for the set points, then we calculated the emissions from those openings. Whenever it opened, we have, next slide, please. You have the quantification piece of the venting from the tanks happening. And all of this from the process data itself. So no atmospheric measurements directly from SCADA. And because we have the point and the perimeter sensors, we have also the data for what they were picking up around that time. So you can see it corroborates what RT-GHG was estimating. I will point out that I expected the whole day to sort of have emissions being picked up by these two sensors. So you can clearly see there's some false negatives there, especially at 8 p.m. There's no data for the perimeter or the point sensor. And what's interesting about RT-GHG is the root cause analysis piece. It doesn't just tell you, oh, hey, there's an event. It allows you to dig a little deeper and figure out if what was causing that event. So what we have here is February 14th. It's we're going to go through just a scenario here, and we picked up the water tank had a vent flow rate. So we looked at the pressure. Okay, yeah, the pressure did spike at around that time, and we can tell that the PVRV opened. But the next question is kind of like, okay, what was happening with the tank? So we look at the water tank level, and we see that the tank was being filled up. So it makes sense that the pressure was being was spiking because you have all the flashing and all the working losses when the tank is being filled up, working pressure. And then, okay, why was the level rising? And we looked at the separator water flow rate coming from the inlet separators. And this one's a little bit harder to see, but you can clearly, well, maybe not clearly, but you can see that there's a hill right around the 12 p.m. mark where it sustains a higher than normal flow rate. It usually oscillates between high and low, but this time it kind of sustained a high flow rate. And the last question that we have is, okay, what's causing this liquid slug to be going to the tank? And we looked at the temperature profile of the inlet separator fluid, and we looked at how that temperature dropped quite a bit or at around that time. And our theory here is that there is a pigging event that's bringing in free water, and the free water is a little bit lower temperature. Again, this is in February, so and we're just working with the client right now to get the pigging schedules and confirm that theory. But the point is, RT-GHG allows you to take a step back and look at what other things are happening in your plant at the time when the tank had that emissions event. However, there are times where we don't see a pressure spike causing an event. We see this pressure dip here, for example, and then the point and perimeter sensors are catching emissions events, which is weird. And these can be attributed to a couple of things. You could have a plume that's kind of migrating on top of the tank farm, and then the perimeter and point sensor are picking up these migrated plumes of methane. You could also have controlled venting. Again, this is a testing facility, so that is a possibility here in this facility. You could even have emissions, actual fugitive emissions, so maybe a hole somewhere that's causing this. Or as we kind of found out, tank unloading events cause this emission spike by these point and perimeter sensors, which is interesting. If you look at the blue line there, you see that the level did go down quite a bit. And it makes sense that the pressure would go down as well, because if your level is going down, it's creating kind of a vacuum inside that vapor space. And it's trying to suck air in. And the weird thing is it's trying to suck air in. So why is emissions being vented to the atmosphere? And the kind of reasoning that we came up with was, okay, if your tank is unloading, that means maybe your truck is loading. And whenever your truck is loading, it's causing that you can model it as a tank again. And if that PVRV is opening, or if it's just open to the atmosphere when the tank is loading, all of that vapor is going to be vented out. And it's important to distinguish between where the venting is coming from, if it's coming from truck or if it's coming from tank, because if you're trying to mitigate these emissions and you upgrade a VRU, for example, that's not going to do anything for you, because the problem is not at the tank, the problem is at the truck. So if you want to mitigate things, it's a lot easier to, you have to understand where your emissions are coming from and what's causing them, essentially. Right, so next slide. So on this slide, we compared the different technologies that we have. So these slides, the 45-degree line there, if all the points fall on that 45-degree line, it means that two technologies agree 100%. That's kind of how you read that graph. And every point on these graphs represents a day. So the total methane emissions for a day, as calculated by a perimeter sensor or RT-GHG, for example. So you can see that whenever the points fall inside the graph, if they're not on the axis, there is some good agreement between RT-GHG and the point sensor. There's not a lot of data there for the perimeter sensor, so I don't want to speak too much about that one, because not a lot of points fall inside the graph. But the points that fall on the axis, they're also very interesting, because these represents on the vertical axis, for example, it represents the false positives. So RT-GHG is not seeing a pressure event, and yet the point and perimeter sensors are. And I just want to make sure that I say this, it's not a false positive that there's no emissions out there. There could be an emissions, but it's a false positive in the sense that these emissions are not caused by your pressure safety devices on the tanks. And on the horizontal axis, if any points fall there, those are clearly false negatives. So we can see the pressure building up and the valve opening, and no emissions reported by the perimeter or point sensor. And the next graph here is just the same data on a different graph. So you can look at the pattern through time. You can see the three technologies kind of have similar agreements. Whenever one goes up, the others go up. Whenever it goes down, the others go down. And there's good agreement between them. Maybe the magnitudes are a bit different, but the pattern itself is good. And just on the cumulative total, so for the entire month, the point sensor and the RT-GHG suite is calculating similar cumulative total methane emissions, while the perimeter sensor is a lot lower than the other two. So just to conclude here, the core capabilities of RT-GHG, what it can give you is that it helped us identify events due to correctly operating safety devices. It has a zero false positive rate. What I mean by that is you're not getting a pressure buildup and then it going down. For sure, we know that a safety device had to open because of your set pressure and because of engineering knowledge. And the other thing is it allowed us to quantify these events based on first principles in engineering and real-time process data. So a completely different methodology than looking at the atmosphere and the concentration of methane in the atmosphere. So it's good for doing checks and balances. So if you have two technologies, one looking at atmosphere and RT-GHG looking at process data, it helps you quantify different ways to get a good comparison. And then lastly is analyzing the root cause. So because RT-GHG is a digital twin of your facility, you can look at exactly what was happening everywhere in the facility at the time of the venting event. And this is in a one-stop shop sort of environment where you can see everything easily and build graphs and analyze two things against each other. So if you have any questions, you can always reach out to us. We'd be happy to answer any questions you have or work with you in anything that you need.
Thanks, Gabe. Thanks, Gabe and James, for that very interesting presentation and for those very interesting results. Now I'll ask some of the key questions that stood out from that presentation. Just so the audience knows, I'll ask a few questions, and then after these few questions, we'll open the questions for the audience. So please feel free to submit any questions, and if we don't get to all of them today, then we'll respond with an email. So question number one will be directed to James. How can a company demonstrate credibility for emissions claims using a real-time plant data monitoring system like RT-GHG?
Yeah, so first I would say transparency. RT-GHG provides a clear record how emissions estimates are estimated or generated, I should say, using actual plant data and rigorous calculations. As well, data-driven accuracy rather than static emission factors or periodic measurements. RT-GHG continuously updates the emissions quantification, leading to defensible emissions estimates. And then finally, auditability. The system tracks all data sources. We got a record, from the SCADA historian, but also what's in RT-GHG, what's being calculated, the methodologies, the data sources, calculation methods. This allows for independent verification of claims that are being made with the system.
Great, thanks, James. The next question will be for Gabe. So how does the data connect to RT-GHG?
Right, it kind of depends on your facility and what you have there. So in Wolf Lake, what they have is that they have a data lake and they put all their process SCADA data in there. And then RT-GHG connects to an endpoint and it gets a data dump every hour. And on that data dump for the hour, it has 10-second increment data for the process itself. But we can work with many different kind of workflows and pipelines for data acquisition. It just depends on what the client has, really.
Great, thanks, Gabe. Second question for James. Can you provide some examples on how RT-GHG can provide a more comprehensive insight into the process versus continuous monitoring devices?
Mm-hmm. And I think my answer here is going to build on a lot of what Gabe had presented in his part of the presentation. He showed how upstream conditions in the separator, for example, can impact tank emissions. There's detectable root causes, which include, for example, inlet separator flooding. As a liquid slug comes into the plant, that could be creating an excess of liquid in the separator and a slug of liquid to the tank, creating that emissions event. But there's others, gas blow-by in the inlet separator, maybe an incorrect PVRV setting, thief hatch failing, upstream heating and cooling. There's a lot of causes that are being measured, and that could be, I guess we could look into that data and potentially identify some of those root causes. And as Gabe pointed out, there's examples where non-process emissions can also be evaluated. As he pointed out, we're not modeling the truck typically, during truck loading. But the system, by virtue of the liquid level decreasing, and potentially with a record of trucking events, that could be used to very conclusively determine what the root cause was in that event. So in summary, continuous monitoring devices, they can detect that concentration spike and detect when that emissions event is happening, but they don't generally identify why that's happening. And so we believe RT-GHG can tie those emissions estimates to process conditions, such as valve positions, compressor activity, flaring volumes, and so on, really helping operators pinpoint those root causes.
Thanks, James. And then, yes, final question for Gabe. How can RT-GHG help the company pursue OGMP 2.0 certifications?
Right, so if you're a company with level 3 and you want to get to level 4, what it requires is equipment specific measurements for your emission factors, and RT-GHG is a real-time kind of emission factor generator. It's in real time, it's calculating what's your load on the heater that you have, what's the load on the compressor that you have, and then it generates the emissions for that equipment. So it would very easily be able to get you to level 4. And to level 5, to get to level 5, you would need to a reconciliation piece between your bottom-up emissions and your top-down. So with RT-GHG, it would give you that bottom-up emissions estimation, and then you can use other studies to use for your top-down. And then reconciliation between these two is key, looking at the timestamp of the two and seeing if they agree with each other. That would give you the level 5 certification for OGMP 2.0.
Thanks, Gabe. So now that I'm finished with my questions, we can open the floor to our audience. Please feel free to ask any questions. Yeah, let's see if there are any questions available.
Yeah, Sophia, I see one. Maybe I'll go ahead and publish it. So the question is RT-GHG approved for Alberta's AltFEMP program and other programs like it? Yeah, so it's an interesting question. I mean, certainly when we talk about AltFEMP or fugitive surveys, it's a type of emission that by virtue of, it's a leaky valve or, something that's not going to be detected by, from your plant, your process data. So I would say, for the fugitive programs, you'll have to use continuous monitoring or your devices, your handheld devices. However, where RT-GHG can help, maybe supplement that. For large emissions events, it talks about understanding the root cause and kind of reporting that, quantifying that. So I think that's where RT-GHG could be an important component of that system. Also, I talked earlier about the example of the BC regulation with the requirement for a continuous device at every tank. And I think is what Gabe showed here today and kind of what we're seeing. Most of the emissions that we see, from those tanks are typically attributed to process related emissions or can indirectly be determined from the RT-GHG system. So we believe that you can actually get a better quantification of those emissions from RT-GHG in the case of tank emissions. And Sophia, if it's all right, maybe I'll ask a question for Gabe.
Yeah,
Gabe,
go for it.
Yeah, maybe can you talk about maybe what's involved with setting up the system for RT-GHG?
Right. So the first step would be to get the engineering drawings, the PNIDs from the client. And then from the engineering, we can create all the equipment and the flow sheet and the connectivity of the equipment and get a good idea of what your process looks like. And also from the PNID, we see where potential tags and transmitters are. So we'll create a list of those tags and we will send to the client, look, do you have these? And there's a little bit of back and forth there. So once we get a good list, a good idea of the tags and the transmitters that we have available, then we create a solution strategy to model your entire plant every 10 seconds, every however often you have data for. And then we can give results from that point on. So in real time, if you want to do 1 hour data dumps, if you want to do 1 month data dumps, whatever kind of the client is looking for at that point. And
Thanks, Gabe.
I'll also talk about the timeline. Usually it's been taking us 2 weeks to get from the drawing to a list of tags. And then another week, just back and forth, 1 to 2 weeks for the nailing down which tags you have on site. So in a month, you could have RT-GHG really set up for your facility.
Thanks, Gabe. So yeah, I think we are running out of time here. So any final thoughts from James and Gabe before we end the session?
Yeah, maybe I'll go first, Gabe.
Yeah.
Of course, we've implemented RT-GHG at a couple of places, continuing to develop that. We see significant application for RT-GHG systems. And yeah, hopefully what we presented here was informative. And if you have further questions or want more insights into how we can support some of those applications, I'd be happy to help. Thank you.
Yeah, I will say the concept of a digital twin is not entirely new, but I think it's the first time where I see a digital twin being used for something. It's not just a concept. It's like James and I have been saying, it's implemented in there, and you actually have the tool working and giving you insights that you care about and not just that are cool. Of course, the tool is cool because digital twins are a nice idea, right? But these are actually useful. So it's one of the first times I see a digital twin being useful, to be honest.
Thanks, James and Gabe. Thank you for sharing your expertise with us today. Your insights are invaluable as we work towards energy efficiency and process optimization in the energy industry. We appreciate your time. I also wanted to mention that Gabe has written an in-depth article on this topic, which goes over the importance of continuous monitoring for emissions reductions. So if you're interested in learning more and you want to use it as a reference for future work, please feel free to visit our website at processecology.com. We will be having our next webinar in the fall, so stay tuned for more information on the topic and the date. And thank you everybody for joining us today, and we hope you have a great rest of your day.